Okay, today we're going to go over drug calculations, and actually this is going to be pretty much a comprehensive review from just basic math to even critical care intravenous calculations. So we're going to pretty much go through the broad range of things you're going to need in the nursing program for drug calculations. And you should be able to use this anytime you need to go back and review. We're going to start off now with a review of calculator skills, and I know that you guys all know how to use your calculator, but I don't want there to be any mistakes just because you weren't using your calculator properly or you weren't thinking about what your calculator was saying. So here's what we're going to do. Always check your answer against common sense. Make sure that when you put it in your calculator and get an answer from the calculator, it makes sense. If you're going to divide by 2, you're going to get a smaller number than you started with. And this is just to check and make sure you didn't accidentally hit the multiply in your speed to get it done. And I know when you're taking those nursing classes that the tests are very quick and that you sometimes are in a hurry to get it done. Have an idea of if your answer will be very big or very small. You know that if you're dividing a small number by a big number, then you're going to have a pretty small number. It's probably going to end up a decimal. Likewise, if you're multiplying a big number by any other number, then you're going to end up with a pretty big number. So have an idea for what the size of the number is. Again, this is to make sure that you didn't accidentally hit the wrong button. Calculators will calculate exactly as you put it in, so you need to remember your order of operations. That's that please excuse my dear Aunt Sally, parentheses, exponents, multiplication, and then division, addition, and subtraction. Now, for the most part, you won't need that in nursing school, but if you want to do one thing before another, you need to make sure you put it in the calculator that way or use parentheses. Most of your calculators you're not going to be able to use parentheses for because these are very simple calculators to prevent cheating or anything like that. Okay, so the next thing that we're going to talk about is when in doubt, put it into your calculator again, just to confirm the answer. You get an answer and something in your gut tells you it's not quite right. So put it into your calculator again, just check. Because we all hit buttons wrong, you know. We're going for the 1 and we hit the 2, or we hit 2 buttons at the same time and you go, I think I hit the right button, but maybe I didn't. Well, there's no harm in putting it into your calculator again, just to make sure you got the right. Okay, so the next thing we're going to do is we're going to review our rounding skills. And before you can round, you have to know place value. So, going from left to right, obviously, numbers can be much bigger than this, and they can go much further into the decimal places and that sort of stuff. But for nursing, you're really not going to need much more than the hundreds place. And then the next one beside the hundreds is the tens place, and then the ones place. The decimal is how we say and. And then after that, after the decimal, everything has a TH behind it. So it's tenths, hundredths, thousandths. And that's how you know where it is, whether it's behind the decimal or in front of the decimal. If it's behind the decimal, then it's going to have that the TH behind it. Another thing I want you to note is that we don't start with oneths, okay, after the decimal. It starts with tenths, okay? So when you're counting your decimal places, remember that the first number after the decimal is always a tenth. And the first number before a decimal is ones, and then tens, and then hundreds, and thousands, and 10,000s, and that sort of thing. Okay? So if we were to have 531 and 67 thousandths, then we would put it into our place value. 5 would be in the hundreds place, 3 in the tens place, 1 in the ones place, and, remember that's how I said it, 531 and 0 in the tenths place, 6 in the hundredths place, and 7 in the thousandths place. So if someone were to ask you what place value is the 6 in, you would say the 6 is in the hundredths place. Okay, now we're going to actually get to the rounding. Some things to keep in mind when you're rounding. To round a number, you're going to look at the number after the requested place value. Okay, so if they say round to the nearest tenths place, then you're going to look at the number after that tenths place. Okay? If that number, the number after the tenths place, is a 5 or above, that meaning 5, 6, 7, 8, or 9, then you're going to round the requested place value, that tenths place, up to the next numeric value. So if that was a 3, then you would round it up to a 4. Okay? If the number after the requested place value is below 5, 1, 2, 3, or 4, then you're going to leave the requested place value alone. Okay? Numbers after the requested place value either become zeros if they're before the decimal, or are left off entirely if they are after the decimal. Okay, so we're going to try a couple. Don't worry if you didn't catch it as I was saying it, we are going to try a couple. So, going back to our example of 531 and 67 thousandths, if we are going to round that to the nearest hundredth place, then we're going to go to the hundredth place, that's the requested place value, and there's a 6 there. We're going to look at the number after the requested place value, which is the 7, that's in the thousandths place, the 7, and is that 7 5 or above or below 5? It's 5 or above, so we're going to round the actual requested place value, which is the hundredths place. That 6 that was in the hundredths place is going to go up to 7. And our new number is 531 and 7 hundredths. Okay? And remember, the thousandths place is after the decimal, so we just leave that off. It's after the requested place value and it's after the decimal, so we just leave it off entirely. Similarly, if I were to ask you to round to the nearest tens place, now remember that doesn't have a TH behind it, so it must be in front of the decimal. Tens place, that would be the 3 on that tens place. We are going to look at the number after that, which is the 1 in the ones place. Is that below? Is that 5 or above, or is it below 5? It is below 5, so we leave the requested place value, that 3 in the tens place, alone. The new number is 530. That the ones place becomes a 0 because it's before the decimal, and everything else is left off entirely because it's after the decimal. Okay? So now we're going to talk about addition and subtraction of decimals. It's very, very easy to do addition and subtraction of decimals. All you're going to do is line up the decimals and add trailing zeros as necessary, and then perform whichever function it asks you to do, whether it be adding or subtraction. So if our example problem is 53 and 45 hundredths plus 21 and 3 tenths plus 7 and 6 ten thousandths. 6 ten thousandths. What we're going to do is we're going to line up the decimals. You see they're all lined up here. And then we're going to add zeros so that every number lines up and you can see exactly where everything goes, and then go ahead and add. That's going to be 0 plus 0 is 6, 0 plus 0 plus 0 is 0, 5 plus 0 plus 0 is 5, 4 plus 3 is 7. Carry down that decimal. It's all lined up in a line. 3 plus 1 plus 7 is 11. Carry your 1. 5 plus 2 plus the 1 that we carried is 8. Okay. If we're talking about doing value for decimals, this is trying to determine whether a decimal is larger or smaller than another decimal. Again, we're going to line up the decimals, and then we're going to compare the numbers from left to right. Okay? So I have several examples here. If I were to compare 3.1 and 3.2, I'd line up the decimals, one over top of the other, and I'd see that my 3's are the same. So I'd go to the next number to the right, which is 1 and 2. 2 is bigger than 1. 1 is less than 2. So it's going to say 3.1 is less than 3.2. Similarly, we could say 3.2 is greater than 3.1. Okay, what if I had 3.1 and 3.01? Again, we're going to line up the decimals, and I see that my 3's are the same. The next number after that is a 1 and a 0, and so therefore the 1 is greater than the 0, and we're going to say 3.1 is greater than 3.01. Alright, so if we were to do a problem that says put 4.1, 4.4, 3.1, and 3.06 in order from least to greatest, again we would line up our decimals, put them all in a line, and I'd first start comparing, and I want to find the least first. So I look at the first number in the ones place, and I see that 3's are going to be smaller than 4's. So I look at those two, and I see that the 3.06, the 0 is smaller than the 1, so that's the first number, followed by 3.1. And now I have to compare the 4.1 and the 4.4. The 4's are the same, so go to the next number in the tenths place, and you'll see that the 1 is smaller than the 4, and so our order from least to greatest is 3.06, 3.1, 4.1, 4.4. We're going to go over fractions, and before we can get into doing the heavy stuff with fractions, I need to make sure everybody remembers all their parts of a fraction. So the top number is called a numerator. The bar in between of the numbers is called a fraction bar. It means the same as division. Just keep that in your head. And the bottom number is called a denominator. Over to the right-hand side, you see that that fraction is 1/4, and the picture is depicting a picture of 1/4. Everything's cut into 4 parts, and 1 part is taken away or separate. Okay, so to add and subtract with like denominators, if they have the same denominator, it's really easy to add or subtract fractions. All you're going to do is simply add or subtract the numerators, and then keep the denominator the same. So, in the case of 2/5 plus 1/5, we're just going to add the numerators, 2 plus 1, that's 3, and keep the denominators the same. That's the 5 on the bottom is going to remain the same, and so our resulting fraction is 3/5. Okay, getting a little more complicated, we're going to go into equivalent fractions. Those are fractions that mean the same. So if you had a pizza that was cut into 4 pieces, one of those pieces would be 1/4, and then if you decided you were going to you had more friends coming over or whatever, and you were going to cut those pieces again, you would end up with eighths of pieces, and so 2/8 would be the same as 1/4. 2 of those little tiny pieces would be the same as 1 of the bigger pieces. So that's kind of what we're doing. Here we're talking about 3/5, and what's the equivalent going to be in tenths? Okay, so to do that, what we want to think about is when we want to take our 3/5 and think about the denominator, that fifth, that 5 on the bottom. And we know that we want to go to tens. So 3/5, the 5 times what will give us 10. So we know that we want to go to tens on the bottom. So 5 times what equals 10? It's going to be 2. What we do on the bottom, we want to do to the top as well. So 3 times 2, because if we multiply by 2 on the bottom, we have to multiply by 2 on the top, and that will give us 6. 6/10 will be our new fraction, our equivalent fraction. Alright, now here comes the harder stuff, adding and subtracting with unlike different denominators. Well, we can't do it, so we're going to have, so if you have 1/2 plus 4/5, we know we can't just add them up. We can't say a 1 plus 4 and then 2 plus 5. That doesn't work. So what we're going to have to do is find equivalent fractions with the lowest common denominator, and then we can add. Okay? So in this case, our LCD is 10. 2 times 5. We're just going to multiply the two denominators together, and that gives us a common denominator. So we need to find the equivalent fraction for 1/2 if we start off if we're using a denominator with the 10 in the denominator place. 2 times 5 will give us 10. What we do on the bottom, we have to do to the top. So 1 times 5 is 5, and our new fraction is 5/10. Okay, we have to do the same thing with 4/5. We got to make it into the tenths place. So 5 times what is going to give us 10? 2. Similarly, what we do on the top, what we do on the bottom, we have to do on the top. So 4 times 2, and that's going to give us 8/10. Now we can add them. 5/10 plus 8/10 is going to give us 13/10, which in nursing you can leave as that, or if you're interested in knowing how it works the other way around, you can also call it 1 3/10. Okay. So to get the value of fractions, again, to be able to compare fractions, you can't compare apples and oranges, so you have to find equivalent fractions with the same denominator. The denominators must be the same. Okay? And then you can compare the numerators because the denominators are the same. Okay, so if we were to write 2/3 plus 2/3, 1/2, and 3/5 in order from least to greatest, we'd get a common denominator. The common denominator would be 30. 3 times 2 is 6, times 5 is 30. Okay? It's not going to be, if you do it that way, it's not going to be the least common denominator, and if you're great at math, fantastic. Certainly get the least common denominator. But it is an easy way to do it, and you can use your calculators to cut things down after that. So your new fractions are going to be 20 over 30 because 3 times 10 is going to get us 30. What we do to the bottom we have to do to the top, so 2 times 10, that's 20. To go from 2 to 30, we have to multiply by 15. 2 times 15 is 30. 1 times 15 is 15. Our new fraction is 15 over 30. To get 3/5 to 30, 5 times 6 is 30. 3 times 6 is 18. Our new fraction is 18/30. Now we're going to compare our numerators. The 15 is the smallest, so it's going to go first because we're going from least to greatest. The next one is the 18, and the next one is the 20. 15/30 is 18/30, 20/30. So we can now say that 1/2 is the smallest, followed by the 3/5, followed by the 2/3. We're going to go over some Roman numerals, and I have just a cute little comic strip in there to get you laughing. What this gentleman is supposed to be from old Roman times, playing golf, and the Roman numeral that he has up there is 4, so he's calling 4. All right. The only Roman numerals that you'll really need in nursing are 1, 5, and 10, I, V, and X. To get Roman numerals, you add the numbers. Add if the numbers to the right are smaller than those immediately preceding them, those right before them. So the I is smaller than the V, so we're going to add them together. V is 5, I is 1, 5 plus 1 is 6. Okay? And then we're going to subtract them if the numbers to the right are larger than those right before them. Okay? So IV, the V is bigger than the I, so we're going to subtract. V is 5, I is 1, 5 minus 1 is 4. And that's how we get the other Roman numeral. IV is 4, VI is 6. Okay, drug calculations. We're going to talk about the abbreviations quickly. Now, in here I have provided you with the Latin names for them. For some people, knowing what it means in Latin helps them tremendously so that they can figure out why the abbreviation works that way. For other people, it's just extra information that confuses them more. If it confuses you more, please ignore it. It's just extra information for those who are interested. Okay? So BID is twice a day, and it comes from the Latin bis in die, which is two times in a day. Bis means 2. TID is 3 times a day, and that's ter in die, 3 times a day, 3 times in day. Sub-Q means subcutaneous. IM means intramuscular, in the muscle. Subcutaneous is in the fat. PRN, it means as needed or pro re nata, for one's need. NPO is nothing by mouth, or nil per os. Nil means nothing, per means by, os means mouth. PR is birectum or per rectum. Q whatever hours. That's Q2 hours, Q1 hour, Q8 hours, whatever, is going to be however many hours. Every 2 hours, every 8 hours, every 1 hour, whatever. And the Latin for that is quoque, whatever ora. IV is intravenous. That's in the vein. PO is by mouth, per os. AC is before meals, antecedem. And ante means before, and sebum means meals or eating. Actually, I think meals. PC is after meals, and that's post. Sebum, like post-operative, after operation. Post means after. Okay, now JCO has put out some abbreviations that should not be used anymore. They used to be used, and now it's just been found that it causes medication errors through confusion. Okay, so this is a list of them. I'm not going to go over them. You can certainly look at them, write them down, read them, whatever you need to do. It's also on the JCO website if you want to look at them that way. But it's things like when you write a U, sometimes when you write a U, it gets confusing because people don't write very well. So it could be mistaken for a 0, it could be mistaken for a 4, it can be mistaken for a CC. And so we don't write unit anymore. The only ones that I will highlight real quick for you are: make sure that you do not use a trailing 0. That means after the decimal point, don't use zeros unless they're absolutely necessary. Don't use a leading zero. That means before the decimal point, don't use a 0 unless absolutely necessary. Use a 0 before the decimal point place, because that will make it more easily understood, and so that you don't miss that decimal point. Another one is MS, MSO4, MgSO4. They get confused. Magnesium sulfate and morphine sulfate get very, very confused. Don't use those. And the last one I want to highlight is the cc, and that's used to be cubic. That was for cubic centimeter. People used to use that. Nowadays we use milliliter. They are the same thing, but the cc gets mistaken for U's and all sorts of things like that sometimes. So we don't use cc anymore. Make a habit, if you're used to calling it cc, make a habit now of saying ml or milliliters. Alright, the basic units of measurement are volume, cup, similarly pint, quart, gallon, liter, similarly milliliter, fluid, ounce, and tablespoon, similarly teaspoon. For length, to determine, volume is for a liquid, length is to determine how long it is. You want to go for meters, centimeters, kilometers, foot, inches, yards. To determine weight, how much something weighs, you want to use a pound, similarly ounces, or a kilogram. For mass, though, mass is similar to weight. It's used for dry measurements, and you want to use gram, milligram, microgram, or grain. Okay, so here are the different measurement systems. You're going to have the metric system, the household system, and the apothecary system. In America, that's what we have. We have all three systems that we still use. The metric is going to include liters, milliliters, grams, milligrams, micrograms, kilograms, all that sort of stuff. Household is going to include cups, gallons, pints, quarts, tablespoons, teaspoons, pounds, ounces, inches, feet, and yards. And the apothecary really only includes fluid, ounces, and grains. You won't see the apothecary as much, especially the grains. Fluid, ounces, you still see a lot. We're going to talk about time real quick. Military time is an extremely useful thing to know. It enables you to look at AM and PM and know which one's which. Oftentimes people take a quick look and they mistake one for the other. They write it wrong, all sorts of things. So this eliminates the confusion. You can look and automatically know whether it's in the morning or in the afternoon, evening. There's no colon when you write it. Just remember that. And AM is always the normal time. So if you say something is at 8 o'clock, it's going to be written as 8 o'clock. Nothing gets changed except that we, because it's a single digit, we do add a 0. We call that 0800. The PM, however, is going to be the normal time plus 12. So if we're talking about 3:30 in the afternoon, 3:30 p.m., we would go 3 plus 12 is 15, and that would be how we'd come up with 15:30. It would be at 15:30. That would be. Okay, we're going to talk about real quick adding and subtracting times, because occasionally you got a patient and they go down for this procedure and they need to get up and use the bathroom and all sorts of things, and so your IVs may stop and start and do all sorts of things, and you may need to know exactly how long were they on that IV. So 42 minutes, an hour 12 minutes, and 38 minutes. What is the total time this IV bag has infused? Well, first you're going to convert them all to minutes by multiplying the number of hours by 60 and then adding the minutes. So 42 minutes stays 42. 1 hour 12 minutes, 1 times 60 is 60. Add the 12 is 72. You get 72 minutes, and 38 minutes stays the same. Then go ahead and add them. 42 and 72 and 38 adds up to 152 minutes. Now you're going to convert back to hours by dividing the 152 by 60. 152 divided by 60 is 2 hours, and you'll have 32 left over. The remainder becomes your minutes. 2 hours, 32 minutes. All right. When we're measuring things, it is important, when we're using measurement devices like a syringe, it is important to note that your needle syringe, you need to withdraw and measure in an upright position with the syringe below the medication vial like you see on the lower left-hand side. Okay? With an oral syringe, I want you to do the opposite. The medication vial should be on the bottom, and you should be withdrawing from the top. Okay? And the reason why is as you're measuring, as you're withdrawing, you should be measuring, and that will enable you to measure appropriately. Be sure to note the line increments on a syringe, okay? Because that will tell you how to measure appropriately. Are those line increments tenths of a milliliter? Are they a half a milliliter? What is that? So that you can measure most accurately. With a dose cup, you always measure that with the cup flat on a surface, on a tabletop, on a counter, something like that, some other flat surface. Your eyes should be at the level of the dose cup so that you're able to determine and exactly where it goes. And be sure again to note the dosage increments. Here you'll note that the long lines are 1 teaspoon and the short lines are half a teaspoon. So if you wanted to find 2.5 teaspoons, you'd go to the second short line. 1 teaspoon, 1.5, 2, 2.5 teaspoons. Similarly, if you want to use the milliliters, the long lines come in 5 increments of 5, and so the short lines are half of that, which is 2.5 milliliters. So if you wanted to find 7.5 milliliters, that would be the first short line. Okay, now we're going to get into the crux of actual drug calculations. Distractors. We're going to talk about word problems and distractors. Distractors are the main problem for most people, one of the main problems for most people when they do drug calculations. It's extra information that is not needed to solve the problem. For example, you may see a problem where it says an adult patient comes into the hospital with an acute infection. The doctor orders ampicillin 500 milligrams IM Q4 hours. The hospital stores ampicillin 500 milligrams in powdered form. The directions for reconstitution state to add 1.8 milliliters of diluent to yield a concentration of 250 milligrams per milliliter. How much ampicillin will the nurse give the patient? Well, that's a lot of information we really don't need to know. What information is unnecessary for solving this problem? Well, you don't care why the patient came. Just in terms of doing a drug calculation, you don't care why the patient came into the hospital. You don't care why they're getting the ampicillin. You actually don't care what medication they're getting. You don't care how the hospital stores ampicillin. You don't care how much of a diluent you want to add. All you care about is how much did the doctor order and what is the concentration of the ampicillin. Okay? So if we were to cut out all the distractors, The new one would say, the doctor orders ampicillin or any random medicine, 500 milligrams IM Q4 hours, and you really don't care about the IM or the Q4 hours. After reconstituting, the ampicillin yields a concentration of 250 milligrams per milliliter. How much ampicillin will the nurse give the patient? That's cutting it out. So you've cut out an entire line's worth of information. Okay, problem-solving skills. Skim the problem. Read it over. Get an idea for what it says. Note the requested information. Get to the question. What does it want to know? Okay? You can't solve it unless you know what it wants to know. What is the problem looking for? Look at that. Underline the important information. If you're a visual person, it helps to just underline the information that you're going to need. That 400 milligrams. That I'm going to need to know that it's Q4 hours. I'm going to need to know that the concentration is 5 milliliters or 2 milligrams or whatever. 2 milligrams per 5 milliliters. Okay? If there are distractors, if the distractors are distracting you, cross them out. Some people, it doesn't bother them, and then you can leave them in. Other people, seeing all those extra numbers and words and stuff like that distract them, go ahead, cross them out. That's not a problem. When you get an answer, always go back and look to see if it makes sense. Okay? For example, you wouldn't give 20 pills, would you? So if your answer is 20 pills, go back and look at that and say, okay, that doesn't make sense. I wouldn't give 20 of the same pill. Maybe I've got a decimal in the wrong place or something like that. And then, of course, rework the problem if necessary. Never, never, never feel bad that you had to go back and do the problem over again just to make. All right, your conversion factors. I said we're not going to use cc's, but you will run into nurses who will still use cc's, so just I want you to know that 1 cc is the same as 1 milliliter. Do not use cc, however. 1,000 milligrams is the same as 1 gram. 1,000 micrograms is the same as 1 milligram. 1 tablespoon is the same as 3 teaspoons. 1 teaspoon is the same as 5 milliliters. 1 ounce is 30 milliliters. 1 grain is 60 to 65 milligrams. The way you determine whether it's 60 or 65 is work the problem. If it comes out evenly, it's whichever one you chose. Okay? That's about as easy as I can tell you. Pick one, work the problem, see if it works. If it comes out nice and pretty and even, you pick the right one. If it doesn't, choose the other one, try it again. It should come out nice and pretty and even. 1 cup is 8 fluid ounces, and 1 kilogram is 2.2 pounds. Alright, I recommend that you do not use formulas to solve your drug calculations. I will be using dimensional analysis in this. If you prefer to use the ratio proportion method, that is perfectly fine, but you're going to need to know that on your own. I don't use the ratio proportion and method. I recommend not using formulas because formulas change with each different type of problem. You need to know this kind of formula if you're doing tablets. You need to know this other kind of formula if you're doing oral syrup administration, or the IM syringes and that sort of stuff. You're going to need to know another kind of formula for IVs. You're going to need to know another kind of formula if you want to find the drip rate of the IVs. You're going to need to know a different kind of formula if you're going to want to do a pediatric. Just lots and lots and lots of different formulas. It's easy to mix up which formula is for which problem. It's way too much to memorize. We have enough to memorize in our nursing classes. We don't want to add more to our brain. It's full enough. And the last thing is it's not easily adaptable. What if the instructor throws out a problem that you didn't anticipate? what do you do then? With a formula, you either know the formula or you don't. Okay, so the reason I use dimensional analysis is it uses the units to help determine how to set up the problems. If the units are right, you know you're right. Okay, so it doesn't matter what problem they give you. It can all be solved dimensional analysis just by figuring out the units. To figure out the units, it's a process of canceling the units. Whatever unit's on the bottom, you cancel it out with the top, or vice versa. It's no memorization, and it works for any kind of problem. So here we go. The way you do dimensional analysis is you first determine what unit is wanted. Go back to the question. Determine the requested unit. In the problem, does it say how many tablets will you give? Then the unit wanted is tablets. Does it ask how many milliliters per hour are you going to give? Then the requested unit is milliliters per hour. You put that wanted unit on top. If it's tablets, you put tablets on top. If it's milliliters per hour, then the milliliters is on the top and the hours is on the bottom, because that per means a fraction bar, which means you put the other one on the bottom. So you always start with the unit that is specified on the top of the problem. And then you're going to fill in your other units via canceling them out. So if you've got milligrams on the bottom and milligrams is not in the wanted unit, then you're going to have to cancel it out by putting milligrams on top in the next section, the next part of your problem. Okay, you put the undesired unit on top if the undesired unit is on top, then you put it on the bottom next time. It's a matter of canceling it out by one's on bottom and the one's on top, and they can't. We're going to do a lot of problems this way, so don't worry if you didn't understand. Okay, so the doctor orders. First we're going to do oral administration with tablets. The doctor orders spironolactone 25 milligrams for a patient experiencing mild heart failure. The nurse has 50 milligram tablets of spironolactone on hand. How many tablets will that nurse administer? Again, the distractor, that mild heart failure, we don't really care about, okay? So, with that in mind, what unit are we looking for? Go back to the question. It says how many tablets. So we are looking for tablets. X number of tablets is going to equal. Okay, so we're going to put that tablet is what we want, so we put tablet on top of our problem. One tablet is how much? What is connected to that one tablet? 50 milligrams. So we put that on. And then we don't want milligrams, because milligrams is nowhere in our desired unit. So it's currently on the bottom. We put it on top so that it'll cancel out. How many milligrams? Go back to your problem. Look, 25 milligrams. So the milligrams and the milligrams cancel out, and what you're going to do is you're going to multiply across and multiply the top and divide the bottom. So you can say 1 times 25 divided by 50, or you can say 1 divided by 50 times 25. It doesn't matter. As long as whatever's on top you multiply and whatever's on bottom you divide. You should end up with a half a tablet. Try another tablet problem. The doctor orders diabetes for 0.1 grams PO daily for a patient with type 2 diabetes. The nurse has diabetes 100 milligram tablets in the Pyxis. How many tablets will the nurse administer? Okay, so what unit are we looking for? Tablets. Alright, so we're going to put tablets on top. And what goes with that tablet? One tablet is 100 milligrams, so we'll put that on the bottom. Milligrams is not part of our desired unit, so we're going to put milligrams on top and determine to get rid of that. Where in the problem do we see milligrams? Again, we've already used the 100 milligrams. We don't see it again. So we need to convert. You convert inside the problem. Milligrams on top. How many milligrams is going to equal that gram? You're going to say 1,000 milligrams equals 1 gram. You've canceled out your milligrams. That is a conversion factor. You cannot use anything in the problem for a conversion factor. It's just the conversion. You need to go back to the conversions. Now we can go back to the problem and say, okay, I have grams on the bottom. Where do I see grams in my problem? 0.1 grams. So we put that on top. The milligrams cancel out, the grams cancel out. We're left with just tablets. So we can do that. 1 times 1,000 times 0.1 divided by 100 divided by 1 is 1 tablet. Alright, so now we're going to work on the syrups and liquids. Alright. A client has ordered 50 milligrams of amoxicillin trihydrate orally. 125 milligrams and 5 milliliters of syrup is available. How many milliliters will you administer? Okay, so what is our desired unit? Go back to the problem. How many milliliters? Milliliters is our desired unit. So we're going to put it on top. What is it connected with? It's 5 milliliters. Go back to the problem. How many milliliters? 5 milliliters. What's it connected to? 125 milligrams. So the 125 goes on the bottom. We don't want milligrams, so we need to find a way to cancel it out. To cancel it out, we'll put it on top. Where in the problem do we see milligrams again? We see 50 milligrams. So we put that on top. And our milligrams cancel out, and we're left with just milliliters, which is 5 times 50 divided by 125, which will give us 2 milliliters. Excuse me. So we're going to try it again. The doctor has ordered promethazine codeine, 1/6 grain, PO Q6 hours, PRN for cough. Again, PO Q6 hours, PRN for cough. We don't care about any of that. On hand is promethazine with codeine solution, 10 milligrams per 5 milliliters. How much syrup should the nurse administer? Now, it does not specifically tell you, but you know that you're probably going to do this in milliliters. So we're going to say that our requested unit is milliliters. We'll put that on top. How many milliliters? 5 milliliters. What does that 5 milliliters go with? 10 milligrams. We don't want milligrams on the bottom because it's not part of our requested unit. So we're going to go back to the problem and see where there are milligrams again. There isn't. The only other unit we see is grains, so we have to convert. We use our conversion factor. We know that there are 60 milligrams in 1 grain, so that's our conversion factor. We know the milligrams are on top of that problem because milligrams were on bottom of the previous portion, so we need to cancel out. 1 grain is on bottom. We don't want grains on bottom because it's not part of our requested unit, the milliliters. So we're going to go back to our problem and say, how many grains are in that problem? It's 1/6 of a grain, so we're going to put that on top. 5 times 60 times 1/6 divided by 10 divided by 1. And that should give you 5 milliliters. Our grains cancel out, our milligrams cancel out, and we're left just with milliliters. That's how we know we're right. Okay, we're going to go into drug calculations with the IV or parenteral drugs. We're going to start off easy. The medication order states that 12,000 units of heparin are to be added to 250 milliliters of D5W. The patient is to receive 1,200 units per hour IV. How many milliliters per hour will the patient receive? So here we go. Our requested unit is milliliters per hour. So we're going to put milliliters on top because milliliters is on top of our requested unit. How many milliliters? Go back to the problem. You see 250 milliliters. What's that connected to? That's connected to 12,000 units. So we put 12,000 units on bottom. Units is not part of what we want on the bottom. We should want hours on the bottom. So we're going to put units on top to cancel out. How many units? Go back to your problem. 1,200 units. That's the other place that has units. And what's connected to that? 1,200 units per hour. So 1 hour is connected to that. Our units cancel out. We end up with milliliters on top and hours on the bottom, so we know we're right. 250 times 1,200 divided by 12,000 is 25 milliliters per hour. So we're going to go on to finding the drip rate. The doctor orders D5LR, lactated ringers, 1,500 milliliters IV to run for 12 hours on a post-operative patient. The tubing has a drop factor of 12 drops per milliliter. How many drops per minute will the nurse count out in order to comply with this order? Doesn't happen very often, but occasionally you do need to calculate the drip rate. Even nowadays, I've had to do so working on a post-op patient because I ran out of IV pumps. So we're going to go ahead and do this. What is the requested unit? That would be drops per minute. So drops is going to go on top. How many drops? Go back to your problem. That would be 20 drops for 1 milliliter. And then we don't want milliliter. Minutes is on the bottom, not milliliters, so we need to cancel out the milliliters. So we're going to put milliliters on top. How many milliliters? Go back to your problem. 1,500 milliliters. And what goes with that? For 12 hours. Okay, so 1,500 milliliters with 12 hours on the bottom. We don't want hours on the bottom, right? Because we want minutes on the bottom. So we're going to have to find the minutes, but the milliliters canceled out. Where in your problem does it give you minutes? It doesn't, so you need a conversion factor. So to go from hours to minutes, you say 1 hour is equal to 60 minutes. And then we go ahead and make sure we've canceled out everything. The milliliters cancel out, the hours cancel out, and we're left with drops on top and minutes on the bottom. And that 20 times 1,500 times 1 divided by 1 divided by 12 divided by 60 is going to give you 42 drops per minute. Please remember when you're doing drops per minute that you can't have a part of a drop. There's no such thing as a half of a drop. It's either a drop or it's not a drop. So you will have to round with drops per minute. Okay? This next one is going to take a little more work, and it's not one you will see very often, but occasionally you will see it on some of your drug calculations exams, and I want to make sure that you're able to figure out how to do it. So your shift is 0700 to 1500. You make rounds at 0730. 7:30 in the morning, and find an IV of D5.5 normal saline is regulated in an electronic infusion pump at the ordered rate of 75 milliliters an hour with 400 milliliters remaining. The order specifies a continuous infusion, so after this one runs out, you'll need to put up another one. At what time should you anticipate hanging the next IV bag? To do this, you're first going to think to yourself, how long until the bag is empty? Now, I'm going to figure it out in minutes because it's a little easier to do it that way. So, how many minutes until your bag is empty? Your desired unit is minutes. And you're going to say, okay, well, 60 minutes on top. 60 minutes, you don't see minutes in the problem, so you need the conversion factor. 60 minutes is the same as 1 hour, so 1 hour on bottom. We don't want hours on the bottom, so we're going to put hours on top. Where in there do you see 8 hours? You see 75 milliliters per hour. So 1 hour on top and 75 milliliters on the bottom. We don't want milliliters either. We just want minutes, so we're going to put milliliters on top. Where in the problem do we see milliliters? 400 milliliters. So milliliters cancel out, hours cancel out, and we're left with just minutes. 60 times 1 times 400 divided by 1 divided by 75 should give you 320 minutes. The next thing you should think about is, how do I convert that to hours? We talked about this earlier. So you're going to divide 320 minutes by 60, and then whatever's left over is the number of minutes. 320 divided by 60 is 5, with 20 minutes left over. 5 hours and 20 minutes. Then you're going to have to figure out at what time is 5 hours and 20 minutes after 7:30 in the morning. So 07:30 plus 5 hours 20 minutes is going to give you 12:50. And so you should be checking and changing the IV bag on or before 12:50 or 12:50 p.m. Okay? That should give you an idea for what you need to do. And this is good things to do for when you've got your patient. Have an idea for when that IV bag's going to run out. Okay, so we're going to go to weight-based and pediatric drug calculations. For the purposes of the drug calculations, weight-based adult calculations are very similar to pediatric calculations. You are going to have to remember your pounds to kilograms conversion factor. We're going to start with, the order is dicloxacillin, sodium 125 milligrams PO Q6 hours for a child who weighs 55 pounds. The recommended dose of dicloxacillin sodium for children weighing less than 40 kilograms is 12.5 to 25 milligrams per kilogram per day. PO in equally divided doses, 16 hours, Q6 hours, for moderate to severe infections. Is this dose safe? The minimum dose, you're going to first do minimum dose, which your required unit is milligrams per dose. It wants to know whether the dose is safe. So your requested unit is milligrams per dose. We'll put milligrams on top. Where in the problem do we see milligrams? Remember, we're starting with the minimum, so it's 12.5 is the minimum. Milligrams per kilogram per day. So kilogram day is going to go on bottom. How do we cancel out that kilogram? Well, where in the problem do you see kilograms? You don't. You see pounds. But we know the conversion factor for pounds. So we're going to put kilograms on top. 1 kilogram is 2.2 pounds. So we'll put pounds on the bottom. We don't want pounds either, so we need to cancel out our pounds. Where in the problem do we see pounds? The child weighs 55 pounds. So we can put that on top. There's nothing that goes with that 55, so we don't need a bottom. We still need to cancel out day, however, because we've canceled out kilograms, we canceled out pounds, but we have not canceled out day. So in one day, there are 4 doses, Q6 hours, gives you 4 doses in one day. And so then we have canceled out day, and we have dose on the bottom. We should be doing 78.125 milligrams per dose. So it is above, that's below the minimum dose should be 78 milligrams per dose, and 125 is above that. So let's see whether 125 is below the maximum dose. The maximum dose is 25 milligrams per kilogram per day. Our requested unit, again, is milligrams per dose. We're going to go exactly the same way. The only difference is we'll be doing 25 instead of 12.5 milligrams. So 25 milligrams per kilogram day times 1 kilogram over 2.2 pounds times 55 pounds times 1 dose, 1 day, 4 doses, It gives you 156.25 milligrams per dose, and that is more than the 125. So 125 fits in the minimum, fits in between of the minimum and the maximum dosage, and so this dosage is safe. Alright, so now we're going to do an adult one. The recommended dosage of tobramycin for adults with serious infections that are not life-threatening is 3 milligrams per kilogram per day in 3 equally divided doses, Q8 hours. What should you expect the total daily dosage of tobramycin to be for an adult with a serious infection who weighs 80 kilograms? So what's our requested unit? It wants to know the total dosage, that would be in milligrams, per day. So that would be milligrams per day. And we're going to put milligrams on top. Where in the problem do we see milligrams? It says 3 milligrams per kilogram day. So we'll put kilogram day on the bottom. Kilograms need to cancel out because it's not part of our unit. How many kilograms? Well, in this case we don't need to convert because they've already given it to us. 80 kilograms in the problem. And we don't need any other numbers because we already have day. Milligram over day is what we have. We canceled out our kilograms, so we just do 3 times 80 is 240 milligrams per day. And that would be what you would expect the total daily dosing for this one adult to be. We're going to go into critical care dosage calculations. This is some of the problems that are a little more complicated, and you'll need to work out a little more. So the doctor orders procainamide, a 1 gram IV in 500 milliliters D5W to infuse at 2 milligrams per minute for a patient you are caring for in the ICU. You should program the IV pump at what rate? So it wants to know, we need to know what the requested unit is. How do you program an IV pump? You program it in milliliters per hour. So the requested unit is milliliters per hour. We'll put milliliters on top. Where in the problem do you see milliliters? 500 milliliters. And where does that go with? 500 milliliters, 1 gram of procainamide. So we put 1 gram on bottom, but 1 gram is not part of our requested unit, so we'll put gram on top. Where in the problem do you see grams? You don't, but you do see milligrams, and we know the conversion factor for grams to milligrams, so we're going to say 1 gram over 1,000 milligrams. There's our conversion factor. And so milligrams is on bottom and grams have canceled out. Milligrams on bottom, we don't want milligrams as because it's not part of our requested unit, milliliters per hour. So we're going to put milligrams on top. Where in the problem do we see milligrams? 2 milligrams per minute. So 2 milligrams is on top, minute is on bottom. Do we want minutes on the bottom? We don't, because it's not hour. We want hour on bottom. So where in the problem do we see minutes? We don't see any minutes in there, but we do know that we want per hour. So we know the conversion factor for that. 60 minutes on top and 1 hour on bottom. And so our minutes cancel out, our milligrams cancel out, and our grams cancel out, and we end up with milliliters on top and hour on the bottom, so we know we're right. 500 times 1 times 2 times 60 divided by 1 divided by 1,000 divided by 1 divided by 1 is 60 milliliters per hour. Okay, so you're going to program the IV pump at 60 milliliters per hour. The next one's a little more complicated than that, and it's the last one that we're going to be doing. Okay. The doctor orders dobutamine IV to increase the patient's cardiac output. The dobutamine is supplied at a concentration of 250 milligrams in 250 milliliters D5W. The doctor orders the dobutamine to infuse at 5 micrograms per kilogram per minute. The patient weighs 176 pounds. At what rate should the nurse program the IV pump? So what is our requested unit again? It's an IV pump, so it's going to be milliliters per hour. So we'll put milliliters on top. Where do we see milliliters? 250 milliliters. Okay. And what is attached to that 250 milliliters? 250 milligrams. So the 250 milligrams is going to go on bottom. Milligrams is not part of our requested unit, so we'll put milligrams on top. Where do we see milligrams in the problem? We don't, but we do see micrograms, and we know we can convert milligrams to micrograms, so we'll use our conversion factor. 1 milligram over 1,000 micrograms. Do we want micrograms on the bottom? We do not. It's not part of our requested unit, so we'll put micrograms on top. Where in the problem do we see the micrograms? 5 micrograms per kilogram per minute. And so we'll put that on the bottom. Kilogram minutes. And we don't want minutes on the bottom, so we'll put minutes on top. Where in the problem do we see minutes? We don't, but we do know that we want milliliters per hour, and we can convert from minutes to hours. So we'll put 60 minutes on top and hour on the bottom. So we've canceled out minutes, we've canceled out micrograms, we've canceled out milligrams, but we have not canceled out the kilograms yet. We'll have to cancel out the kilograms by putting kilograms on top. 1 kilogram. And what do we want to put on the top there? We want kilograms. Where do we see it in the problem? We don't see it. We don't see it in the problem, but we do see pounds. So we know that we want to convert kilograms to pounds. So 1 kilogram is 2.2 pounds. We don't want pounds in the pounds is not part of our requested unit either. So we will cancel that out by putting pounds on top. Where in the problem do we see pounds? 176 pounds. So pounds cancel out, kilograms cancel out, minutes cancel out, micrograms cancel out, milligrams cancel out. You end up with milliliters on top. You end up with hours on bottom. You're good to go. 250 times 1 times 5 times 60 times 1 times 176 divided by 250 divided by 1,000 divided by 1 divided by 1 divided by 2.2 should give you 24 milliliters an hour, which is what you should program your infusion pump for. This concludes the drug calculations lecture. If you have any questions, please see here.